The next question is 25 ml of a dilute aqueous solution of para-hydroxybenzoic acid is titrated with an aqueous solution of 0.02 molar NaOH. pH of the solution is found to be 4.57 on adding 8.12 ml of NaOH solution. Further, pH is found to be 7.02 after the addition of 16.24 ml of the same NaOH solution, that is same concentrated NaOH solution, which is correspond to equivalence point pKa1 and pKa2 respectively for that dibasic acid is. So remember that here it is para-hydroxybenzoic acid, which is an example of a dibasic acid. This hydrogen is acidic hydrogen, active hydrogen. This hydrogen is also acidic hydrogen. And this hydrogen of hydroxy group of acid, COH, acidic hydrogen, is more acidic than hydrogen of OH group. So in the first neutralization of this para-hydroxybenzoic acid with NaOH, this H will react with OH minus rather than this. So the first neutralization reaction that takes place during the reaction is equation 1 corresponding to Ka1. In the next step, this para-hydroxybenzoate further reacts with the NaOH, that is OH minus added to give plus H2O. This equation corresponds to Ka2. So thus there are two reactions taking place, and it was observed that by the time 16.24 ml of 0.02 molar NaOH is added, equivalence point is reached. So complete neutralization of this para-hydroxybenzoic acid is taking place. But in the first instance, by the time 8.12 ml, which is exactly half of the same NaOH is added, the pH is found to be 4.57. So from this, what is that we can understand? So 8.12 ml of the same NaOH being exactly half of the equivalence point, half the neutralization takes place. In other words, complete equation 1 will take place. And half the neutralization corresponds to the concentration of HO, C6, H4, COO minus formed and the original acid taken. This will be equal because it is half the neutralization. So this is the very important point. And at this stage, the acid left over and the salt with strong base formed, that is the COO minus Na plus. It is the salt of strong base and weak acid. And here is the weak acid half neutralized. So half of the weak acid will be left over and the salt of it with strong base is formed. That is a buffer with a special case of the concentrations of these two being equal. So since this is an acidic buffer with this condition, it is pH is equal to pKa. Since salt concentration is equal to acid concentration is the very important point to be understood. And that is given as 4.57. So therefore, we have pKa as 4.57, first one. Now further you can consider that this para-hydroxybenzoate which is formed is amphoteric substance. And for such cases, the equivalence point. So this is another one which is to be remembered well. We have pH is equal to P of Ka1 plus P of Ka2 by 2. And what is the pH given at the complete neutralization or what is called equivalence point? We are given 7.02 in the problem. That is equal to pKa1, which we got it as 4.57. So can't we find out pKa2 from this relation? So we get pKa2 on solving as 14.04 minus 4.57 comes out to be 9.47. So one answer is 4.57, another answer is 9.47. So therefore, we have 4.57 right, but 7.02 is wrong. 4.57, 14.04 wrong. 7.02, 2.45. So this is what we got on solving. So this is one of the important questions where you need to concentrate.